So much to see in the sky and shadow. I'm loving the memories. Feels like a dream. It's a beautiful world. You always been home to me. So much to see in the sky and shadow. I'm loving the memories. Feels like a dream. It's a beautiful world. You always been home to me. Feels like a dream. So much to see. Oh, oh. Feels like a dream. In the sky and shadow, I'm loving the memories. Feels like a feels like a dream. So much to see in the sky and shadow. I'm loving the memories. Feels like a dream. It's a beautiful world. You always been home to me. So much to see in the sky and shadow. I'm loving the memories. Feels like a dream. It's a beautiful world. You always been home to
Dzień dobry. Działa.
Oh, I've been tired of looking over my shoulder late. Tired of always trying to be. Oh, I gotta tell you, I'm going crazy.
Raz jeden, próba mikrofonu, próba test.
Just wanna do it my way. Don't want you to keep me from trying to fly. You always made a fool out of me. Couldn't even tell what was on the ride. Ooh, I don't wanna live a lie. I just want from you. You changed like you locked me out of your space. And half your calls are wasted. You know you got me worked up. Want you to look at me for real. I'm hanging up. I never wanna stop. Staring at the summer night sky that we belong in. Do you feel this far away from me? You changed like you locked me out of your space. I see you every day, every full moon. Wait for you every day, ever so soon. Want you to look at me for real. It's getting harder to remember. Or have we always been so bittersweet?
walking on the beach all night in the moonlight. Stay by my side, stay by my side. It just felt so right. I saw a light flash by my eyes. Stay by my side, stay by my side, stay by my side. Stay by my side. We were walking on the beach all night in the moonlight. Stay by my side, stay by my side. It just felt so right. I saw a light flash by my eyes. Stay by my side. I got a feeling that we're never letting go. Now that you're with me, I just gotta let you know. When we're together, we won't ever be alone. Stay by my side, stay by my side, stay by my side, stay by my side. Stay by my side, stay by my side, stay by my side. Got a feeling that we're never letting go. Now that you're with me, I just gotta let you know. When we're together, we won't ever be alone. Stay by my side, stay by my side.
Hey now, letters burning by my bed for you. Hey now, I can feel my instincts here for you. Hey now, by my bed for you. Hey now.
Raz, dwa, trzy, cztery. 4, 3, 2, 1. Jest ok. Dobrze. Raz, dwa, trzy, cztery. 4, 3, 2, 1. Ok. Dobrze, dzięki.
So I go insane, like I always do, and I call your name. She's a lot like you.
Good afternoon. I think that we can start the not presentation, but the conference that is organized as a part of the Water Sea Management project that is dedicated to the water reuse in the wastewater and water sector. It's my great pleasure to open this event, the Water and Sewage in the Circular Economy Model. This is the international conference that is supported by the Norway grants. And today I have the great pleasure to welcome all participants from Poland and abroad who had found the time to join our event. I know that weather is not very optimistic now. 2 years ago we had 33 degrees Celsius here during the July. However, I hope that here it's quite hot and there will be a lot of hot topics that will be discussed during this 3 days conference. The conference is organized by the Division of the Biogenic Raw Materials in the Mineral and Energy Economy Research Institute of the Polish Academy of Sciences. I know it's a very long name of our institute. And I have to underline that this event is co-organized by our host, and this host is Kraków Water Utility. And we are very, very thankful for the all staff and members of the Kraków Water Utility that we have the pleasure to be here because it's a really special place and castle, but I will let the president to say few more words about it because I know that this is also the intention of second presentation. I don't have anything to change the slides. Okay, sorry. The conference is, of course, organized in the partnerships and support of many different institutions. And this year we have the support from the Kraków city, who also published the information about the conference in the social media and official web pages of the city. So we are very thankful for this collaboration in the form of the partnership. We also have the support of the biggest platform dedicated to the phosphorus, European Sustainable Phosphorus Platform, and today we will have the opportunity to hear the presentation of the former president, Mr. Ludwig Hermann, about the raw materials in the water sector in the next session. There are also partners who should be underlined here. That's the partners in our project, and this is the COWI, Aqua Team COWI from the Norway. We have also the Polish company Greenback and Foundation Optimus that are very active partners in our Water Sea Management project. Here I also have to underline the patronage of our conference. So the patronage was taken by the Polish Academy of Sciences, and I'm really happy about that because I represent Polish Academy of Sciences and we are really working on the water aspects and recovery of raw materials from the waste generated in the wastewater treatment plants. Our conference is also supported one of the biggest network association dedicated to the water and wastewater companies in Poland, Chamber of Commerce, Polish Water Works, and here also we have representatives of this institution, so you will have the possibility to talk and to collaborate, including Dr. Clara Ram, who also has the presentation about the water reuse aspects in the invited session regarding the projects on the water reuse in Europe. The next honorary patronage was taken by the Polish Ministry of Science, and this is also the institution that is involved in the education for the water management, so we are really happy about that. And the last honorary patronage was taken by the National Fund for the Environmental Protection and the Water Management, and this is also the operator of the program of Norway grants, which was also connected with our project. The honorary patronage also was taken by the International Water Association Poland chapter with Professor Jacek Mąkinia, who will give the speech in this session, who is the president of the Polish chapter. And also we have the media patronage of the three institutions, Krakow, the first one. The second one is the journal that is published by the Chamber of Commerce, Polish Waterworks, and the last one is Forum Exploatatora, which is also the technical Polish journal that is publishing a lot of papers dedicated to the water in the circular economy. The plenary session, the agenda of the plenary session includes four invited presentations and my introduction to the Water Sea Management Project. So we will start with I hope it will be short introduction from my side. Then we will proceed with the presentation of the president of the also very short presentation of the circular economy in Kraków Water Utility. Then we will proceed with the presentation from Roberta Metafone from European Commission, who is responsible for the implementation of the water reuse regulations. And in the aspects of the last week and 2020, I think it's very important to have some news about the regulation dedicated to the water reuse in Europe. The next presentation will be given by Professor Jacek Mąkinia on the climate neutrality. We know how ambitious goals of the European Green Deal we have to be climate neutrality in 2050, so it's very important also to evaluate this aspect in the wastewater treatment plants. And this is very hot topic now, so it's a very nice presentation, I hope. And the last presentation, but not the least, will be given by Professor Alfonso Meya from the Penn State University. And we will finalize this session with the global perspective for the water management, which will be given by the global experts, I have to say. Okay, so now I think we will proceed to the next, to the introduction of the project, because this is something what I have to provide. So today is also the special day. I'm very happy about it because this is the Earth Day. It was not my intention when I was searching for the date, the best date for the conference. However, we are very lucky because honestly, the water is this is the most important resource on the planet. Without the water, there is no life. So this is actually the true information. The second one, the water is very important element of the sustainable development and is included in the sustainable development goals, which also will be discussed today, how we could increase the water, access to the water in some regions, including Europe, because I assume that we are thinking that, okay, we have the normal access to the water and this is not a problem that we will face in the future. But honestly, we will face this problem in the future and our Polish agriculture is facing this already. And of course, the water is also one of the elements of the climate change activities that we have to together take as a way to the sustainable future. Water management is an important part of the circular economy. This is in the line with the topic of our today conference, the title of our conference. And from the perspective of the sea implementation in Europe, and definition of the sea, we have to be in the line with two areas. First, we have to provide more sustainable management practices for the primary sources of water. And this is something where water and wastewater companies are responsible. And the same for the second area, that means wastewater management, water-based waste. And also the wastewater and water companies here have a lot of chance to provide the new technologies, to implement the technologies, and also education elements. To face the problem of the water management including the area of Poland. We have proposed in 2020 the project dedicated to the development of the technology for the water recovery and reuse, and to have a huge campaign, education campaign, dedicated to the various groups of the stakeholders. The main objective of our project was to strengthen the implementation of the circular economy in Poland, because it was connected with our call. And the call from the Ministry of Climate and Environment was dedicated to the circular economy, and from the almost 100 proposals that have been submitted, only 5 have been financed. And that was also our project in the area of the water management. The specific objectives includes 3 elements. First was dedicated to the installation of the water reuse and recovery. The second one was dedicated to the international collaboration between Polish and Norway countries, and also to have some transfer of knowledge between the scientific and non-scientific institutions. And the last one was dedicated to the education on the water management among different stakeholders groups. And today in the afternoon session, the last session today, we will present the results, specific results dedicated to the recovery technology and also to the social campaign, because we are very, very proud that we have proven that we reached 3 million people. And everyone who is working in the projects, you know what is KPI, and that you have to prove the KPI in some way. That means signing the list of participants or so on. So we have reached 3 million people. It's really, really fantastic result for our project. This is the team. I know that we are not very gender-friendly here. We have almost all women. However, maybe we are working for the gender equality, because in the past, the water and wastewater sector was mainly associated with the men. So we are the women who would like to be involved also in this green transition, and we are working very actively on this part dedicated to the technology and also to the education. And our call was dedicated to the circular economy, and we had during last 2.5 years almost 2 million zlotys for the technology and education. And honestly, this month is the last month of the project. So you can imagine that after the conference, it will be crazy reporting everything from our project. This is something what I just put here to interest you to join the last session today, because Dr. Dariusz Żuka will present the results of our installation. And honestly, the tomatoes from this installation were very good, and we are still alive. It was around 200 kilos we produced. So yeah, just to say this, and Dariusz will say more. Education campaign, that is the part that I was mainly responsible in our project. As I mentioned before, we have reached 3 million people, more than 3 million people in Poland, so it's really fantastic number for us because we assume 1 million people. We have organized a lot of workshops, seminars, summer school, education videos. Now it's conference, we have blog on our webpage. There is a lot of different education methods that we have provided, and we are really happy that it happened. And now, of course, we will use those materials in the future because that's the open materials and everyone could use it, including, for example, webinars that were invented for the students. So they are available for free on our YouTube channel as well. So if you would like to have some materials that have been proposed by us, you can join our webpage. Here you can also find the program of the conference, book of abstracts for the conference, and also our channel in LinkedIn, because this is the main area of our social media where we are providing the information about any event and activity that we are doing in our division. conference. This is 3 days. Today we start in the noon, and then there is second invited session dedicated, of course, to the water and circular economy in water and wastewater sector. And the last session today is dedicated to the projects that are working on the water reuse and water management in the European countries. Today evening, I would like to invite you to the gala dinner that will be organized in Cossack Hotel, so at 8 in the afternoon. If you will have a time, please join us. There will be quite a nice event, I hope. The second day, tomorrow, it will be a really busy day because we will start early in the morning and we will finalize the conference in the afternoon. There will be the regular session, and there will be in the morning the special panel session where we will discuss the collaboration and some challenges for the water sector from the perspective of business and also from the perspective of the scientists. And also we will talk a little bit about the competences for the future experts in the circular economy in water sector. The last day is like really connected event because we have a lot of activities. In the morning there will be a panel session which is connected with the study visits in this place. So you will have the possibility to go around and also to go the next building to see the installation for the water reuse. The next sessions will be dedicated to our accompanying event, which is Phosphorus Conference, also connected with the water and wastewater sector, because we are working on the phosphorus recovery from the waste generated in the wastewater treatment plants. And there will be 2 sessions, and the last session, the closing session, we will have the invited experts as well, and also we will provide the awards for the companies that applied for the best examples of the circular economy in water and wastewater sector. So that's 3 very busy days. I hope you will stay with us to the end of this event. Yeah, and this is our second event that is organized the last day, as I already mentioned, Phosphorus Conference, and that is also supported by the Visegrad Fund, and is connected with our other project dedicated to the development of the roadmap for the phosphorus management in the Visegrad countries, and also some results of our project will be presented 24th of April. And now I would like to give the floor to our president of Krakow Water Utility to say more words about the circular economy in this very beautiful place and also in all company. Mr. Piotr Ziętara.
Mogę prosić o prezentację? Dear guests, dear participants of the conference, of the circular economy in water sector participants of that conference, I'm very glad and honored that I can invite you into Krakow, to our very beautiful city, and also welcome you to Krakow Water Utility, the second largest utility in Poland from the water sector, one of the biggest companies in that area of Europe. And I will try to give you some details or try to draw the bigger picture of the company during my introduction. But it's not the company presentation as it used to be, but it's only the small presentation about about the venue, about the place, about the spot where we can meet today and tomorrow and on Wednesday. But from the beginning, I would like to wish you a very fruitful meetings, building the bonds, networking during the conference, but you have a very difficult challenge in front of you, because I saw the agenda, and this evening is quite late. The supper is at 8, and probably that most challenging issue will be to attend the first session for tomorrow. And I see that many of them agree with me. And I think that that challenge is in front of you. And I wish you all the best for attending for tomorrow morning session. But starting with the water utility, Kraków Water Utility, that's the oldest power company. It was commissioned on the Valentine's Day on 1901. It means that it's the oldest part of the modern water company in Krakow. Now it's treating only, I have also nice picture describing the plant. That plant is still operating. From the beginning is treating water for the city, for the municipality. Now the share of the production in the general sale is around 10, maybe 12% of the volume, and I think that's the future of that plant is very crucial for us. It's not the share of the water which is treated here, but it's the share which can be provided during the next generation, maybe next decade. I mean, treating the Vistula River water, or taking the raw water from the Vistula River, which is now quite polluted river in Poland. And that challenge is in front of us to restore the intake on the Vistula River, to have something like a backup plant for the water supply in the municipality. Our main source of water is the artificial lake, artificial reservoir, which is placed 35 kilometers from Krakow, which is supplying about 65% of the provision of potable water to the city. And I think that's the most precious part of the company. Unfortunately, you have a very busy agenda and you can't visit that plant. But if there is a possibility in the future, we can organize the visit to that plant during the next generation of the circular economy in water sector conference. And you are all invited for that technical visit. What is important in water sector in Poland? And because I'm very glad that we are talking today and tomorrow and on Wednesday about water and wastewater. Usually the circular economy is applied only to the waste management or the solid waste management. Now we are trying to draw the attention to the water sector in way of thinking about the circularity. And it's extremely important also, especially during after the pandemic and after the outbreak of the war, we discovered that the water, that resource is crucial for the future development of the cities or the future development of the societies. And that's why that point of thinking that we are dealing with the circularity in that area is important for all generations, not the current generations, but the all future generations. And we are also the part of building the future of our kids, of our next generation, trying to protect the raw water, trying to protect the sources of water for the municipalities and for the future inhabitants, future dwellers of the cities. But we are also we are also facing the different kinds of challenges, the different kinds of risks, and I would like to give you some examples which can be also linked to the circular economy. I mean the electricity. It's not the case of during that conference, but you have to be aware that water companies usually in Western world are trying to build its own sources of electricity. I mean building some kinds of independence from the grid, which is usually managed by the state. I mean the own sources, also building the possibility of getting some kind of the share of passive part of the operational costs, which are not paid to the state-owned companies as a providers of the electricity. Fuel is also important. We are trying to reduce the usage of fuel. Labor cost, the risk is maybe it's very small relation to the circularity. But the climate change is the key issue. It's the key issue because we are trying to limit the climate impact of our activities. All actions which are conducted by the companies should be done in the way which is the first and the most important goal is to limit the climate impact. Of course, at the beginning, we are trying to mitigate that impact. Or at the second stage, we are trying to build the resilience. You know about the heavy rains in the municipal areas. You know about the floods, which are extremely dangerous, especially in such cities as Krakow. It's one of the hot topics in our city. All efforts which are related with the circularity or the circular economy are connected with the level of tariffs. I would say that that word could be given as a description of that risk as a level of affordability. It can't be too expensive, but it can't be too cheap. You know exactly the issue which is called as a right to water. Right to water is also related with the economy. And that economy is the is a base for the decision-making process of the managers of the water companies. EU funds, access to the development of financing the future development. Costs of funds, I mean the cost of money, the value of money, especially after our outbreak of war, we had extremely large inflation rate. In all European countries, of course, the rate was different in each country, but the outbreak of war caused the explosion of inflation rate, especially the customer inflation rate index. Pandemic. We don't remember the pandemic. It was recalled after outbreak of the war. The 24th of February 2022 was the day of closing of issues regarding to the pandemic. But pandemic is still surrounding us. War, I said a lot about it. Supply chains, also important. And cost of materials, and finally, with something which is very foggy, which is difficult to describe, is a cyber security. It's also important issue in the in the way of managing the water sector. But we are trying to mitigate that risk which were given. There were only some examples where you can build that list with many icons. But that examples was the most important examples for company which is managed by our board. But what we do for the mitigation? We are trying to use the renewable energy sources. I mean turbine, producing or generating the power from the streams, from the rivers, from the solar energy, from the turbines built in the trunk networks, because we want to increase the share of our own electricity, own volume of electricity, which is put in the mixture of the electricity which is used by the company during the production. Extremely important is also that the own sources usage is building also the backup sources for the plants, for water and wastewater. Wastewater is also the critical infrastructure. It's not only the case of the water sector, of the water production, water treatment. And closing the loops, I mean the circularity, using the grey water, reusing the treated wastewater as a water used, which is called in Poland grey water or technological water. It doesn't mean what the name is. but it's used for the cleaning, for maintenance of the city, but also for watering the greenery. It's used by the Department of Greenery in Krakow municipality, but also by our services for the maintenance of the wastewater network. We are not using the potable water because potable water is too expensive for that and too precious for us. And of course, at the end of the process of thinking about circularity, which was mentioned before, all is included in the final retail price for water and wastewater. And that's our role, to limit the increase of tariffs, to build the affordability on the highest level as we can. And finally, I would like to because I had only 10 minutes, but I would like to summarize that introduction, let's say, with 4 very nice words describing the way of thinking, way of managing the water company. The first word is reciprocity. I mean, managing the stakeholders, internal and external, building the bonds, understanding and listening to the stakeholders. Listening to the society, to the community, listening to employees. That's important, extremely important when you want to build a modern company. The second word is clear, circularity. It doesn't need to be explained. The third word is sustainability, also very clear. And the fourth was given before, affordability. All people in Poland, in each country, must be able to cover the cost of potable water, which is provided to them on the highest possible quality. And I wish it to you for every day in future. Thank you very much.
Thank you very much, President Ziętara. Energy, economy, minerals, water, I think this is directly connected with our institute. So we are very happy that we could collaborate on this issue dedicated to the sustainable water management and also education, and also the next study visit that was promised here. I have a lot of questions for that. Thank you very much. And now we will proceed to the next presentation that will give you the overview for the European perspective for the water reuse. And I would like to invite Dr. Roberta Maffeton from the European Commission to give us a speech which kind of news we have in the water reuse on the European Commission scale. Roberta, the floor is yours now.
Thank you very much. And thank to you, Marteja, for the invitation, and to Dr. Clara Ram. I'm very happy to be here in this part of Europe where water use is something that was some novelty. I've been discussing water use mostly in the southern European countries. It's very nice now to see what is going on in this area too. So I am Roberta Maffettone, and I'm a scientific project officer at the European Commission's Joint Research Center. How do you go? Oh, okay, thank you very much. So the Joint Research Center is the European Commission service for science, for policy. So there are 5 centers in the European Union. I'm coming from the one located in Italy, which is focused on, my department is focused on sustainability, and my unit is working on water. So what we do, we provided independent scientific advice to the department of the European Commission to draft policy and program in the European Union. So why water use in the European Union? It is a strategy within the European Union for resilience for water. So in the territory of the European Union, 38% of the population is affected by water stress, and 29% of the territories is affected by water scarcity. The recent drought events, they are being recorded not only in the southern region of the European Union, but also in the eastern and western Europe. So it's becoming a problem throughout the territory. Agriculture is the sector that is most affected by drought. It's been calculated that when there is a drought event, in all the sectors, the agriculture is affected by 50% of the total loss. Also, agriculture is the main sector for water consumption, so the water that's been abstracted and used and is not going back to the original freshwater resources. So 60% of the water is consumed by agriculture and forestry. Other sectors are also contributing to water consumption, like, for example, the industrial sector. Agriculture water is also the second sector in the European for water abstraction, so water that is abstracted from groundwater and surface water. There is also water scarcity. This is an indicator. It's called Water Exploitation Index that measures the water consumptions as a percentage of renewable freshwater resources available in a territory. So when in an area that is higher stress, this index is above 40%, and this is happening mainly in the southern region, southern countries of the European Union. I highlight Poland, that is below 20%, so it's not in the underwater stress so far. We have the water use is considered as a strategy in the European Union to preserve freshwater resources and increase resilience to water stress. Those are some of the strategies and actions where water use is considered. There are several communications, like a blueprint to safeguard Europe that was published in 2012. We have strategies like the European Green Deal and the new Circular Economy Action Plan, where water use is one of the main elements, and the Zero Pollution Action Plan. There are other legislations going on that consider water use, and they have been revised and soon to be approved. On the left is the Urban Wastewater Treatment Directive, where water use is encouraging water use beyond agriculture and irrigation. So in the overall circular economy concept, including reuse for industrial application and reuse for environmental applications. It's promoting reuse also by imposing better monitor, control, and reduction of pollutions for micropollutants. So this revision of the Urban Wastewater Treatment Directive is looking at planning to add quaternary treatment to remove micropollutants from the water, and this will contribute to the reuse of these resources. On the same way, the Industrial Emission Directive it's aiming to encourage recycle water in industrial settings by minimizing the emission of pollution in the environment. So the water use regulation was approved in 2020. It's a regulation that was needed in the European Union to harmonize and standardize the requirements that the quality of water coming from urban wastewater treatment plant had to meet in different member states. So all the member states that they were actually reusing water for agricultural irrigation had different parameters, different requirements, but there was a need to harmonize these requirements in the view of also the free movement of the agricultural products within the European Union. So a standard for all the countries to protect the human health and the environment. So what the regulation regulate, it's the effluent from urban wastewater treatment plant, reuse in agriculture irrigation, define minimum water quality requirements, but also risk management provision. So it requires to assess any risk, and gives the mandatory the transparency. So to give to the public the information about water use, make it available. It's very quickly, is dividing, the minimum requirements are divided in 4 classes of water depending which crop is irrigated and which irrigation method is used. This will determine if the crop, the agricultural product will be in contact directly with the reclaimed water or will be not directly in contact and it will be processed. There are the minimum requirements are microbiological and other chemical parameters, very few, like E. coli, BOD, TSS, turbidity, because the regulation imposed to identify additional requirements by doing a risk assessment on a water use system. So second requirement of the regulation is to do a risk management plan that would identify in a water use system if there are any risks, any hazards in this reclaimed water that could affect the human health and the environment, and to determine how to manage this hazard on each water use case. At JRC, so at the Joint Research Center, we support the draft of the regulations. Those are few of the publications that they have a topic water use. The 2 on the left, the first one in the red box is the one that supported the drafting of the regulation on minimum requirements, and the last one, it's guidelines on how to do this risk management plan on water use system. We are still working on this, so there will be more publications to come on the topic. We have been working, we have been present and working with the working group on water use established by the European Commission. They are groups where representatives from the member states, they are at the same table, and they read and they discuss the regulations and the guidelines, and we take into account all the opinions from the different member states. So with this participation, supporting the European Commission, to the European Commission, we publish 2 additional documents for the implementation of the regulation. It's a guidelines on the regulation itself, and also a legal act on technical elements of how to do this risk management plan. What is the status of the water use regulation in Europe? So far, the member states, they are adapting their national legislation to the regulation. So it's a regulation, so it applies in toto in all the member states without transfer like a directive. What the member states need to do, they need to decide if they want to opt out water use because of a particular characteristic of the territories. For example, availability of fresh water or to maintain the ecological flow of the rivers. So they might decide not to do water use in agriculture irrigation. So far, this is a map of where water use was allowed. When the regulation enters into force, the rules in June 2023, the green are those where the green countries are those that water use was already allowed, so they are working on adapting that. And pink are those that they are planning not to reuse water for agriculture irrigation. I just highlight this part of Europe. So currently, what we know is Germany is currently working on a national legislation for water use in agriculture irrigation. Estonia will allow water use. And Poland, Latvia, and Lithuania are considering to opt out with Article 2, so not to reuse water for agriculture irrigation, but they might reuse, they might regulate for reusing for industrial and other activities. This is the last two documents that the European Commission published to support the implementation of the regulation, the guidelines, and this technical specification, which is will enter into force in May, on 13 May 2023. So very, very soon. Less than 1 month. Those are very quickly the elements of the risk management plan that is that water use system are asked to draft to ensure protection to the human, the animal health, and the environment. There are 11 elements that requires to the first element requires the complete description of the water use system with the identification of the responsible parties and also all the hazards, the assessment of any risk, identify any treatment or actions in the water use system to reduce the risk, including any procedures and protocols. Just to highlight that this risk management plan takes into account the whole water use system from the entry point of the water in an urban wastewater treatment plant to the final uses for agriculture irrigation. So also identify any risk to the environment that is surrounding. Then final, very 2 minutes to talk about our technical workshops. So since to support the implementation of the water use regulation, but also to promote water use beyond agriculture irrigation in the European Union, we are organizing currently online technical workshops where we ask experts from all the member states to present case studies and to try to understand what is going on in any specific country. I selected a couple of them that were relevant to this part of Europe. One was on industrial reuse, so focusing on case studies from the European Union that were using wastewater from municipal wastewater treatment plant to reuse in their industry. So instead of taking potable water and or fresh water from groundwater or rivers, they are getting the water from the urban wastewater treatment plant. And there is not a regulation on this, but the industries, they analyze through risk assessment and they identify the quality that was fit for their use. And they show how a risk management can be done in an industrial settings to protect the workers that they are using the reclaimed water for the process. The main process that where water is reusing is a cooling system for petrochemical industries, washing and pulp and paper. And we also had a presentation from Dr. Clara Ram presenting what the potential of reusing water in industrial settings in the Baltic Sea region. We are planning to have a next workshop in September. It will be online, so if you are interested, you just can email me and I will add you in the mailing list. And then a second workshop was on environmental applications, where municipal water is reused for irrigation of parks. There were 2 examples of irrigating urban parks in Lisbon and in Madrid. Still, where a risk management approach is taking into account to identify a quality of water that is fit for that use, and it looks at protecting the people that will use the parks. And also in this workshop, we have another presentation from Dr. Clara Ram, looking at how water is used in the Baltic Sea region for amenity-related activity, including the production of snow or the cleaning of the street for urban uses. So very few conclusions, and the regulation is 2020-741. It applies for agricultural irrigation, and its implementation is ongoing in the member states. New legislations that they, like the Urban Wastewater Treatment Directive and the Industrial Emission Directive, will facilitate water use within all the territory of the European Union. There is a potential of reusing water beyond agricultural irrigation, and this is specifically in the western and the eastern countries of Europe. We still have many challenges that will be addressed. We are trying to address with our work, mainly how to do this risk assessment, this risk management plan in the water use system. But also there is also the public perspective if water use is good for the health and for the environment. We'll continue to support this. We'll continue to give you information on the water use practices to give confidence to the public about this very good opportunity that we have to save a very precious resource. And we will continue with the scientific advancement to support policy in the European Union and with our technical workshops. Thank you very much. Those are my contacts in case you need.
Thank you for this very nice presentation, Roberta. I have to say that we did not apply the regulation for the water reuse, despite the fact that with Clara we were working very hard with the Ministry of Infrastructure to push them to implement this regulation. However, as you can see already from our previous presentations, we are doing this in our project. We are doing water reuse, and also in Kraków Water Utility, the technical water is already used in many applications, what was already underlined. Thank you very much for this very nice presentation of the European perspective. And now I would like to give the floor to the next speaker, who is Professor Jacek Mąkinia, who is representing the Gdańsk Technical University and also is a president of the International Water Association chapter in Poland, and will say few words or more words about the climate neutrality in the wastewater treatment plants and how to evaluate these aspects. Thank you.
Go on this side. Good afternoon. First of all, I would like to thank Professor Marzena Smol for the invitation. It's my pleasure to be here for the second time to attend the Circular Economy Conference. And the topic of my presentation today is carbon neutrality of wastewater treatment plants. But in fact, I will be talking about carbon footprint. Carbon footprint classifications in wastewater treatment plants, calculation examples, significance of nitrous oxide emissions for the carbon footprint, and some examples of modeling N2O emissions. And then I came up at the end with mitigation strategies of greenhouse gas emissions, how to approach the state of carbon neutrality. So first of all, we need to remember that the main goal of wastewater treatment is to protect the public health and water environment. However, in recent years, two more important issues appeared, which are important for sustainable wastewater treatment, which is resource recovery in the circular economy and greenhouse gas emissions. It is estimated that wastewater treatment plants emit large amounts of greenhouse gases. It is estimated that it would be even 3% of the total amount, especially N2O, nitrous oxide, which could be up to 5%. And the carbon neutrality was addressed is addressed in the new EU wastewater directive, and it is said that the sector could play a significant role in reducing greenhouse gas emissions and helping the EU achieve its climate neutrality objective. So the total emission of greenhouse gases is calculated based on carbon footprint. And if we go to wastewater treatment plants, carbon footprint is composed or consists of two parts: direct emissions during wastewater treatment and sludge disposal, and this is under scope 1. We have carbon dioxide, which is normally not included in calculations of the carbon footprint in wastewater treatment plants. Then we have methane and nitrous oxide and N2O, which is highly variable and provides a high contribution to the carbon footprint. On the other hand, we have indirect emissions, which are associated with energy supply under scope 2 and material consumption under scope 3 for transport and chemical usage. So this diagram is illustrated in this figure, which shows the main points of direct emissions of N2O, which is the biological stage, especially the aerated part of this bioreactor, aerobic zone. And it is estimated that roughly 90% of the total N2O emission originates from the biological stage, from the bioreactor. Methane, 70% is typically emitted from anaerobic digesters and dewatering processes. As you can see, energy supply is external, and also as under scope 3, transport and chemical usage are external to the wastewater treatment plants. So for carbon footprint, it's not only the total emission of greenhouse gases in terms of amounts of the mass units, but also the global warming potential of each specific gas is very important. And normally we calculate this global warming potential based on 100 years horizon compared to CO2. So that's why this global warming potential of CO2 is 1. And then, as you can see, for methane it's almost 30. And then for nitrous oxide, N2O, is almost 300. So what are the consequences? This is one of the first early examples of greenhouse gas measurements in wastewater treatment plants, a plant in the Netherlands. And you see on the left side, you have the mass units, a lot of carbon dioxide, very small amount of N2O. If we look at the equivalence, taking into account this global warming potential, the situation is completely different. 85% of N2O, and then just 5% of CO2. So how can we estimate the greenhouse gas emissions? Measurements, quite difficult. We can only measure those emissions at selected points, at least at this stage of the measurements. So normally we use empirical fixed emission factors, which are based on experience, based on the measurements from different plants and calculated as average. And a very promising approach are mathematical models, either mechanistic or machine learning. So There are several tools for calculating carbon footprint based on those emission factors. On the left side, you have so-called Swedish tool, which is actually an Excel spreadsheet consisting of 13 pages with the inputs from wastewater treatment plants, main results, and assumptions, including those emission factors. On the left side, you can see a German tool, which is available online. And for one plant in Poland, we compared those two tools, and the difference in the result was not very big. It was less than 5%. Using the tool, the Swedish tool, this spreadsheet, we apply this for several wastewater treatment plants in Finland and in Poland in collaboration with Aalto University. And the results are quite interesting. This is just a summary of the results. I do not want to show you the details. But if we look at the structure of the carbon footprint, it seems that they are similar. So the dominant, the direct emissions had the highest share in the total carbon footprint, and two emissions dominated the direct emissions, and energy consumption dominated the indirect emissions. You may see a small difference in the energy input between Poland and Finland. In Finland, it's lower because Finland has in the mix energy mix, they have higher content of renewable energy. That's why this energy impact is lower in Finland. But if we look at the results, the final results, it turns out that Finland has the average carbon footprint is much higher compared to Poland. There are several factors affecting this issue. First of all, the higher nitrogen load in Finland. It is related to the diet. They eat more protein than that we use in Poland. Also, in Poland, as you can see in the upper part, most of wastewater treatment plants use energy recovery. It does not happen in Finland. So let's look closer at the Polish results. So there was one plant which had a very high carbon footprint, and this was exception because there was no biogas production. Then we had another group of 3 plants that had biogas, anaerobic digestion with biogas production and electricity and heat production. So this was the medium group, and then the first group with the low carbon footprint. And this was related to the recovery, nutrient recovery by composting. So this was an offset. So replacing the artificial fertilizers could provide some positive effects on the carbon footprint. Another example, this is an ongoing study from China. I'm working with my colleagues from Tongji University on some wastewater treatment plants in the Shanghai region. This is just a preliminary study, but the results are quite interesting because, as you can see, the structure of the carbon footprint is completely different in this country. 1/3 is related to direct emissions in wastewater treatment, 1/3 to energy use, but also because of high chemical usage, also this scope is represented in a high amount. Specific carbon footprint is between Poland and Finland. But by the way, does it say something to you? This number 50 should be 50 kilograms CO2 per population equivalent per year. So if you take, I was traveling from Gdańsk to Krakow, and this is more or less one way of traveling by car. This is the same amount of carbon you use for the whole year treatment for one person. Okay, I mentioned about the importance of N2O. So highly variable, high contribution. So we used for our studies, for our calculations, the reference value from the IPCC, International Panel on Climate Change, which is 1.6% of the influent load. But in the literature, you can find a very broad range of these emission factors. So we ran a sensitivity study using extreme values found in the literature, low range, high range, and as you can see, the results are completely different. So it means that the N2O emission itself could change our carbon footprint by 100% increase, or it could decrease by 50%, depending on the assumed emission factor. So a good approach, a very promising approach, is modeling. I mentioned about the global warming potential. I mentioned about high uncertainty. And there is also a third reason for modeling N2O emissions. This is because N2O is an intermediate stage of two important processes for wastewater treatment, which is nitrification and denitrification. So also from the scientific point of view, this study is very, very interesting. For modeling, just going very quickly through this stage, for modeling, measurements are very important. So for model calibration, for model validation, we needed at least single points where we can measure those emissions. And you can see two examples from two wastewater treatment plants in the aerobic compartments where this emission is highest. Very simple, or very simple and not very simple, but the equipment consists of floating hoods installed directly in the reactors, and this is the main player, which is gas analyzer. Results, just final results. As you can see, the model was very accurate in terms of the nitrogen compounds and also emissions. Left side, plant A, it looks like it has higher emissions compared to plant B, but in fact, if we compare this emission factor for plant A, which is estimated based on modeling by simulation, it is more than 40% lower than the recommended IPCC. What is the consequence? Almost 1,000 ton CO2 equivalent reduction of the annual carbon footprint of that plant. So with the model, with the calibrated, validated model, we can try to optimize the conditions to decrease the carbon footprint. And it turns out that by manipulating the dissolved oxygen concentration in the aerobic zone and internal recirculation, we can obtain not very great results. It would be only 10%. We could reduce the carbon footprint by rather relatively small amount. So 10% is not much. But anyway, this is the first step. Process optimization is the first step towards mitigation of the direct greenhouse gas emissions and achieving the state of carbon neutrality. And this is probably the most economical solution in the existing plants. The other solution, there are two other solutions. The first one is just capturing and treatment of the gaseous streams containing the greenhouse gases. Some people say that this is not a feasible solution. But if you look at the future, the wastewater treatment plants of the future in China, there are a couple of examples of wastewater treatment plants which are fully covered. And actually, the plant on the right side went into operation in 2021. And the next, the last strategy is to prevent emissions by applying new process configurations with energy recovery and new processes which are based on a well-known process called ANAMOX, anaerobic ammonia oxidation, which is alternative compared to nitrification and denitrification. And this is actually the proposed configuration of such a new plant, consisting of 3 stages, actually. The first stage is carbon, but not carbon removal, but carbon adsorption or absorption and redirection for anaerobic digestion. So basically, we should avoid carbon oxidation in this stage, just capturing carbon and redirecting to anaerobic digestion for biogas production. Then in the second stage, nitrogen removal in Anamox-based systems. Anamox, the energy consumption in Anamox is at least 4 times lower compared to the classical conventional nitrification, denitrification. There are a lot of challenges for this process, but I think this is not the right place to talk about the details. And then the third stage, post-treatment for other advanced wastewater treatment processes. So instead of conclusions, some take-home messages. Wastewater treatment plants produce large amounts of greenhouse gases, especially N2O. Direct emissions have the highest share in the total carbon footprint. In typical, I would add, in typical medium and large wastewater treatment plants having anaerobic digestion. Nitrous oxide share in those emissions is could be more than 50%. There is a high uncertainty in predicting N2O emissions from these empirical emission factors. That's why modeling is a promising approach. Not only the mechanistic models I showed you, but also we have tried machine learning models, and the results were also very, very encouraging. I mentioned those 3 strategies: capturing, minimization, and prevention of greenhouse gas emissions. And I should add at the end, resource recovery is needed to obtain full carbon neutrality. I mentioned about this composting, about nutrient recovery, but also based on those preliminary studies from China, it looks like water reuse is even more important offset for achieving the state of carbon neutrality. So if you are more interested, we have published a review paper on net zero carbon condition in wastewater treatment plants in journal Renewable and Sustainable Energy Reviews. And I would like to thank my big team at Gdańsk University of Technology working on this issue. Thank you for your attention. Thank you.
Thank you, Professor Monkinia, for, I think, very deeply going to the topic of the carbon neutrality in the wastewater treatment plants. Take-home message, the recovery of resources at the wastewater treatment plant is one of the strategic elements of the carbon neutrality and neutrality in the future. So thank you very much. And now I would like to invite the last speaker in this session, very good friend of mine, I have to say, Professor Alfonso Meya from Penn State University, who will talk about the global perspective of the circular economy in water sector. So Alfonso, the floor is yours. Maybe you would like to join the stage.
Sure. Yeah, thanks. Yeah, so thank you for the invitation. It's great to be here and in this beautiful setting, and you know, I'm really happy to be here and talk to you. So how much time do I have? I ask because I'm a professor, otherwise I can go on for, you know, endless amount of time. So 12 minutes, okay, yeah, we'll make it work. And yeah, I have to clarify, I mean, I have to start with a negative note, I guess. I was very ambitious with my title, and or the other interpretation is, you know, I'm from the US, so global to us means the US. So the emphasis of my talk is going to be on the U.S. and specifically virtual water and water footprints in the U.S. And that's an area where I've done a lot of work and where I think there is a lot of room for integrating circular economy into these virtual water and water footprint sort of frameworks and ideas. And I'll show you a little bit of, so the plan is I'll show you a little bit of the results that we have gotten and try to use that as, and that's something that we're working on right now, use that as motivation to develop a more general framework for a circular economy in the water sector that involves sort of virtual water and water footprints. So briefly, I'm professor at Penn State University. So I'm sure that you all know where that is, but just in case, so that's Pennsylvania right there, and then I'm showing the location of Penn State. The name of the town where the university is located is State College. Before I moved there, I'm not sure that I will be able to tell you where State College was at the point. No, but it's right in the center of Pennsylvania, and that was done on purpose. They put the university in the center of the state where there is not much going on, because they were, to avoid having sort of issues between Pittsburgh and Philadelphia. Both cities wanted the university in the city, so they decided we just put it in the center so that we are far away from all the major cities. So we are 3 hours away from New York, 3 hours away from DC, 3 hours away from Philadelphia, so that they achieved the goal. So it's a large research university. It's about $1 billion in research expenditure per year. Here are more pictures of Penn State. And this is what we're known for too, American football. And believe it or not, the stadium has 100,000 seats, so it's slightly bigger than Camp Nou or Wembley, in the middle of nowhere. So. All right, so I'll start my presentation with my conclusions, keeping in mind that I was going to take too long, so I might as well just get the conclusions done and then I'll show you some results. So the main point that I want to make is that if we are talking about circular economy in water management, we really need to look at water footprints and virtual water. That's something that we're already doing with the carbon and carbon footprint. One way of saying this is water is the new carbon. That's not my quote. Many people have said this, but we're not giving water enough importance. We're not giving virtual water enough importance, but we need to, and it's as important as climate. I think all of us here that are in water know this already, but it's important to reemphasize this idea that water is as important as climate. And one way of maybe accounting for that importance is using virtual water. And I'll define virtual water in a second, but if you and the way we do this is, the way we account for virtual water is we use data science, we use network science, we can also use artificial intelligence, and that's creating new opportunities for quantifying these water footprints, virtual water, and modeling these things at a large scale. That at least coming from the US, there is a lot of interest from the business side in understanding these indirect water dependencies or virtual water flows. Maybe from within the water sector, the interest is mixed still, but maybe this is going to be driven by business in the future. But by virtual water, I mean sort of the water that is embedded in the supply chain. So if you look at different products, right? So cheese has a high amount of virtual water. If you account for all the water that is used in the production of cheese, then you end up with a high water footprint or virtual water content. Meat, hamburgers, and you heard this before. So that's this. One way of interpreting this is that if we want to reduce water footprints, then we need to change our diets. I think that's one alternative. And the main point that I want to make is not whether we need to change our diets or not. The main point that I want to make is that even if we change our diets, that may not translate to a big impact in terms of virtual waters if you are not looking at the full supply chains and everything that is going on in the supply chains. That I think is something that we learn from other systems, and this is something that we see in the US when we look at these virtual waters and supply chains, is that these are these are complex systems, and lessons that we learn from other complex systems is that even if you make a lot of good decisions that are at a small scale, right? So a small scale here means a consumer that decides to make a different choice to reduce water footprints, or a farmer that decides to use less water when irrigating, and so on. So we have a collection of these good small decisions. These small decisions, even if there is millions and all of us sort of making these small, they may not translate to good decisions at the larger scale. That there is a larger scale that has its own principles, its own patterns, its own regularities that may not coordinate well with the small decisions. So you need coordination at different levels, and to coordinate at different levels, you need to understand what's going on at the higher level. So that's something that we try to do, understand what do these water footprints and virtual water look at a higher scale. So we combine a lot of data. So this includes employment data, business data, water use data, and we end up with a network, right? So we divide the US into different locations. The nodes here are geographic locations. And we have different versions of these, but in this version, we are looking at major cities, and then we have all the states in the US. So we have 50 cities and 50 states. We have networks that these are the supply chain transaction between these points that we can convert into virtual water. So we can, we know how much virtual water is moving across the whole US. Here is just the population of the city, but you can see on the west is Los Angeles with a very high population, and New York City on the east. Those are the two largest cities. We can account for interactions between cities and states, state and cities, and also importantly, you start already seeing here some circularities. We can account for this self-loop, so a city that is exchanging with itself. But there are circularities at all scales, so not only local, but if you start looking at a large geographic area, you start seeing that this circularity happens at all levels. So in principle, we need to be water efficient at all scales, not just local. So here are some pictures of the types of network that we have for different types of products. So these are food products, but we have also industrial products. In principle, we are accounting for the entire economy of the US, the product economy, not the service economy or other economies. So this is, I'll maybe jump to the one finding that we have. So the one thing that we find, I think that is so we have several findings, but this one, I'll jump to this one as a way of ending. So we find that this network shows what we call community structure. This is a concept in network science. But basically what that means is that there is an organization, regional organization in the network. So we obtain this using virtual water, but you start seeing that there is these regions where the virtual water flows are more intense than with the rest of the country. So you start seeing, I think we find seven of these regions. You can see there is one in the middle that is aligned with the Mississippi River, and that makes sense. There's a lot of trade that happens along the Mississippi River. There is a northeast region, there is a southwest region, and these are virtual water regions. And you can delineate boundaries to these regions, and these boundaries are different than watersheds or river basins. They are different than aquifers. We call them hydroeconomic boundaries. So right now, at least in the US, water management policy is based on water physical boundaries. Obviously, that's more intuitive. So we're arguing that there are these other boundaries that may be more relevant for policy, or at least as relevant as the physical boundaries. And in order for us to make progress in water sustainability, we're going to have to start accounting for these sort of macro patterns that emerge from the economy, from the data itself. And unless we account for these type of patterns, I will argue that even if we made a lot of progress at the local scale, that progress may not translate into positive changes at this larger scale, because at this larger scale, there are other patterns and rules and principles that are governing our water systems. So I'll stop there. Thank you.
Thank you very much, Alfonso, for this short presentation. I'm sure that you wanted to say more, but we are in the pressure of time. Water footprint. This is something what Alfonso is expert. Carbon footprint. Professor Monquinha, I recognize that is studying this topic as well very, very deeply. So that's the elements of the green and circular transition. Thank you for this presentation. And I confirm that State College is in the middle of nowhere. I was there on the scholarship in 2022, just after previous conference, this one organized here, and I was also surprised that there is nothing. And in the middle of nothing, there is huge university with one of the biggest laboratories that I haven't seen in my life, not one of the biggest, the biggest laboratories under the ground, many floors, so it's really, really impressive, and also this university is included in the list of the top universities in the world. So Alfonso is working as an excellent expert there for the water management. Thank you very much for all prelegents in this session. I would like to now close this session officially. And for practical point of view, today in the afternoon we have the gala dinner, yes, but please be tomorrow here early in the morning. As well, because we will start with the panel session, and there will be real discussion between the experts from the business and from the science, and also from the associations dedicated to the water management. So it will be quite interesting, and you will be also asked some very nice questions. So I really, really invite you to join tomorrow morning after gala dinner in Cossack Hotel on the roof of hotel. Another important information for today, now we will start, of course, the break, but firstly, I would like to invite all participants of our conference to the joint picture that will be taken just now after this session. So please come here just after session, and thank you very much for your presence here.
Okay, good afternoon, ladies and gentlemen. Please take your seats. We are just a little bit after time. It's time to start a session with the title Water, Energy and Raw Materials in Circular Economy and Sustainability. My name is Beata Szatkowska, and I represent Aqua Timkowi, which is R&D and consultancy company and research institute from Norway. We deal with different environmental issues. I myself, my background is chemistry and civil engineering, and work a lot with wastewater treatment and organic sludge management. And today I have a pleasure to chair this session. We have 1 hour and 4 speakers, so please keep your time. It's probably maximum 13 minutes. And I will start with Ludwig Hermann, who is a well-known expert working with nutrients management. And today he will present us successful stories related to nutrients and energy recovery from wastewater. Ludwig, the floor is yours.
Okay, thank you, Beata. Thank you for your kind introduction. And so I will talk about wastewater as a resource and the wastewater treatment plant as a resource recovery plant. And if we look at our current situation, we need to decouple. We need to decouple the materials use from our living standards, or from our consumption that we have in total. And the problem is that we have a finite planet with finite resources, and we have an economic system that is built on growth. So these two movements cannot really nicely go together. So we need to recycle more to reduce the extraction of primary resources. We have a common target. These are the Sustainable Development Goals, and 6 of them are directly related to water and to water use and to water as a resource. And we have global activities, one of them within the United Nations Environmental Organization, and we had several resolutions already on nitrogen and nitrogen-related activities, and the goal is to halve nitrogen use or nitrogen losses by 2030. So this is a very ambitious goal, which is in line with the Green Deal and Farm to Fork goals of the European Union. For this purpose, the European Union, the European Commission, has a number of targets, a number of legislative acts, and also strategies. And we talk here about the Urban Wastewater Treatment Directive that is currently under recast, and we have already a kind of agreement that says that we need to recover and to recycle resources from wastewater. We have the Critical Raw Materials Act, in which phosphorus is one of the critical resources, but it is not a strategic resource for Europe. We have the Sewage Sludge Directive, of which recast is planned for the next session, for the next European Commission. We have the recycled nutrients in organic farming. From last year, first time Sewage from wastewater is now licensed for use in organic farming. We have the Soil Health Directive. We have the Green Finance Taxonomy that considers phosphorus recycling as one of the technologies that deserves being financed under sustainable economy principles, and we have the new fertilizing product regulation that provides a level playing field for primary and secondary resources. We have currently 2 countries in Europe that make nutrient, or particularly phosphorus recycling from wastewater, mandatory. One is Germany and one is Switzerland. And Austria has presented a draft that is currently under consideration, I would say, not yet passed the parliament, so it's not yet enforced. Looking at the wastewater treatment plant as a resource facility, we have, of course, on a global scale, we have still 80% of wastewater going down the drain unused and, of course, polluting groundwater, rivers and lakes and oceans. And we, let's say, let unused, unrecovered energy, chemical energy, thermal energy, nutrients, and of course the water reuse. So it is currently more a threat to human health and to the environment than a benefit. On the other hand, if we use the resources, we have heating, cooling, power, biomethane, chemicals, nutrients, coagulants, and binders that we can recover from wastewater. And therefore, we can also have benefits and also commercial benefits from its use. A very good example for this is the wastewater treatment plant Turku in Finland. So it's different to the wastewater treatment plants that you consider. They produce 10 times more energy than they use, 10 times more. And they do that by having heat pumps, producing district heating by heat pumps, and therefore having a very positive energy balance, which is the heat pumps are much more influencing their heat balance or their energy balance than the biogas plant that they also have, but it produces much less. If we talk about the nutrient potential, in Europe we use approximately 1.1 million tons of P in the agriculture, mainly in agriculture, and we have the technical potential to replace all of this by recovered nutrients, 1/3 of it approximately being recoverable from wastewater, much more from agricultural residues, and part of it also from bio-waste and from slaughterhouse residues. We have a number of positive cases, positive success stories, among others the direct use of sewage sludge, but also this practice carrying the risk of particularly emerging pollutants being not only accumulated, but also presenting a direct threat to the population and to the health, soil health, and of course to our food chain. We also use wastewater to produce algae. Algae for different purposes, but the simplest one is just to have a higher energy recovery rate in the anaerobic digestion plant, in the biogas plant. We have, as I already mentioned, we have struvites produced in wastewater treatment plants in several European, American, Canadian, and also Japanese plants. This is or could be a very clean product that is now also licensed for use in organic farming, and it's the first phosphate fertilizer that can be used in organic farming apart from rock phosphate, which was not very plant available when it was used. We have, of course, biochar as one of the thermal processes for use of sewage sludge. We have different processes for recovery of phosphate from ash after sewage sludge incineration that is dominant also in Poland, but also in Germany, in Belgium, in the Netherlands. So in a few European countries, in Switzerland, most of the sludge goes to an incinerator. We have a thermal treatment facilities. We have thermal treatment facilities for producing fertilizers out of sewage sludge ash, where the function of these processes is mainly making the P in the ash plant available. We have technologies currently under development, among others, to recover iron phosphate from sewage sludge or from anaerobic digestion by magnetic separation. In ammonia, this started, or in nitrogen, it started later than the phosphorus recovery. And we had now congresses dealing with white ammonia. We call it white ammonia, or Mark Sutton invented this term for recovered ammonia. We have technologies like ammonia stripping already in frequent use in different plants. And we produce from this stripped ammonia, ammonium sulfate or ammonium nitrate or ammonium phosphate, depending on the acid that we use for reacting the ammonia, the gaseous ammonia. We have a Norwegian technology which is using a plasma technology for enriching agricultural slurries with nitrogen. And we have also different technologies for recovery of ammonia from the aqueous phase. So we have different facilities also for nitrogen recovery. In all of these cases, we must take care of also of the life cycle balance. It is not automatically so that the recovery is beneficial in terms of the environmental footprint, the total environmental footprint. So if we have a complex flow sheet for our recovery process, it is important that we extract not only nitrogen or ammonia or phosphorus, but also other elements from sewage sludge or from the residues of the wastewater treatment plant. So we are at the beginning of a movement, of a process, of a trend, and therefore, if you look at the recovered products, we are still at a very low level compared to the use that I mentioned in the beginning. So we recover currently approximately 12,000 tons P2O5 as struvite, and we recover some 37,000 tons P2O5 as ash-derived products, partly as phosphoric acid and partly as calcium phosphate. So we have plenty of room for increasing the balance here. And if I conclude, we have many technologies available. Many of them are already mature for industrial implementation. We need, at the global scale, higher efficiency. We need to reduce losses. We need to increase reuse and recycling, including from water, of water, but also of nutrients and other elements from wastewater treatment. And we need exploitation of low-grade resources. And our waste flows usually are low-grade resources. We may be regionally already competitive in terms of nutrient recycling, but at a large scale, it's it's still a cost involved. It's not a profit. We have a high technical potential and also a, let's say, considerable practical potential. Of most estimations, including of GRC, are around 30% real potential. And we need also business models that provide and promise a higher resource efficiency, like resources as a service. And I thank here Veronica Santoro, who has supported me in completing this presentation, and I thank you for your attention. Thank you.
Thank you, Ludwig, so much. I think we will leave the question at the end if any time will be left. It was very interesting. However, right now, Idiamo Dadamo from Sapienza University will tell us about the green hydrogen. Idiamo.
Thank you very much. First of all, thanks to Marzena for your kind invitation, and also team of Marzena, because this is possible because there is a group, and in particular for the female components of the group, because I have checked the number of last 5 years related to Sustainable Development Goal. Before we have seen the 17 Sustainable Development Goal. The number 1 of SDG is the number 13, climate action. The last is peace and justice. Unfortunately, in the 16th position, there is the gender equality. And so we have a need to have several tools to implement. My name is Idiamo Dadamo. I'm very happy to be for the 4th consecutive year in the top of 2% as research in the field of sustainability. With Professor Gastaldi and Professor Morone, we have elaborated a new definition of sustainability and published in Journal of Cleaner Production. You can check the test. I think that is not necessary to read, but I have a question. You are sustainable, you are selfish, you have never think if these two terms are related between them. We have tried several social surveys, and thanks to this social survey, we have demonstrated that typically people that is happiness toward the other people is also sustainable. So, sorry for the people that love environmental protection, but sustainability is not only environmental protection, but it is a big and a more complex situation. And I am grateful for Marco Giannini, that is a winner in the last conference in Poland, that has supported me in this project. We have started with the calculation related to the fuel. Instead, we concentrated on the role of hydrogen. Why hydrogen in a conference of water? We try to explain the connection. It is a simple agenda. Before to analyze several points, we have a need to see some point related to the literature. Literature has demonstrated that during the conflict of Ukraine, we depend from the gas of Russia. Hydrogen is alternative, but hydrogen is not a new component of energy. It is an old technology, but thanks to the new challenge related to the Green Deal, we see the potential of green hydrogen. We have tried in Italian people to ask the difference between green hydrogen and gray hydrogen. I don't ask if you know the difference between gray hydrogen or green hydrogen. In Italy, the 70% are not idea of this difference. Gray hydrogen do not support sustainability. Green hydrogen has this support. We can check the social aspect that the literature has a need of more attention. And finally, we can see that the number, in particular economic aspect, we have a need to investigate. It is not my paper, but when I have read this work, I'm very impressive. the amount of water necessary to produce energy. For 1 megawatt hour of energy, we have a need of 43 liters related to the wind energy. To the photovoltaic 330, you can check that are the lowest situations. So the water is necessary to produce energy. For this motive, we have a need to recover this water because it's not a resource that is always available. In this presentation, we will investigate an economic analysis related to the production of green hydrogen. We consider the production of renewable energy from a photovoltaic plant, and before we have seen an electrolysis, and so we try to identify the production of the hydrogen. We use a simple equation in order to calculate the levelized cost of hydrogen. We have a component related to the capex and opex for hydrogen, and also the levelized cost of electricity related to the production of energy. There are some assumptions, a lifetime of 25 years, cost opportunity of capital of 6%. In order to produce 1 kilogram of green hydrogen, we have a need of 9 liters of water. And we can see that the first year we are able to produce 20,000 kilograms of hydrogen, but during the time is not available to produce the same amount. It is a small plant in this case. The number is the following. The levelized cost of electricity is similar to 0.07 euro for kilowatt hour produced. The cost of levelized cost of hydrogen is 3.65. It is the cost, not the price. There is a big difference because there are economic aspects of other stakeholders, so it is the cost. We can check the distribution of cost in discounted terms. We can see there is an half between the production of electrolysis and the production of energy. But typically, in particular, when we analyze the economic perspective, the economic perspective is based on assumption, but the assumption is objective or subjective. In some cases is objective, in other is subjective. So my suggestion is always to provide alternative scenario. So we have varied the critical variable, the capex opex of hydrogen, the energy cost, and in green we can see the sensitivity analysis. So we have changed only one variable. In yellow, in scenario analysis, we have changed two critical variables. We can check that the value change, but not in a significant way. So our results are consistent. Another interesting analysis is the risk analysis. We consider the distribution through the Gaussian probability associated to the critical variable, and we can check that 84% are related to the range 3.30–3.90 euro per kilogram. So, after this presentation, we can conclude on some point. When I start 10 years ago, the concept of sustainability is a little topic. Today is a big topic, but there is a difference between ideological and pragmatic sustainability. Ideological, this water is sustainable. No thanks. We must demonstrate that this water supports the process of sustainability. And sustainability is a point of contact between social progress, economic opportunities, and preservation of environment. If one of these points is not well analyzed, it is not pragmatic, but it is ideological sustainability. I am against ideological sustainability because we continue to live with fossil fuels, with an ideological perspective. Theoretically, we are a sustainable community, but what is a sustainable community? People that speak, people that try to change, people that change your habits, people that listen young, in a good balance between older generation. Taxes and subside. Green energy has a need of subside in order to be competitive, in particular not, for example, in Italy, but in developing countries. We have a need of taxes, for example, emission trading scheme. Fortunately, now the cost of carbon dioxide equivalent is 100 euro for tons, but about 3 years ago is equal to 5. Water. We have demonstrated with the previous number that water is a constrained resource. And another, we can see that the green hydrogen supports the development of clean and affordable energy. So the Sustainable Development Goal number 7. The next slide, I don't report it because we are in Poland, but also in the last appointment in India, with the Organization of Global Journal Flexible Systems Management, I have used the same slide because about 20 years ago, we have a new definition of sustainability provided by Saint John Paul II. If you live with young people, you will also have to become young. And so it is the mission of Idiano life, but I think of several life, is because we are probably the sentinels of the morning. So in particular for the young people that are in the left side, I hope that there is each dream can be real if you want and you try. Finally, because of the water, is my city, this is, because it is a good natural visit, but it is possible if we have contracts the climate change. Alternative, it is not possible to visit this wonderful point. Finally, an aspect to the presentation after Professor Castaldi will explain better with the name of the project, Peace, because also here in Poland, we are very near to the other territory. We hope to see, visit, and to attend Peace in all parts. Thank you very much.
Thank you very much for a good reminder. What does it mean, sustainability? Yes, we will stay with Italy. Massimo will present us, or actually will answer the question. Is the, sorry, I can't read that perfectly, but we can, yes. Yes, and are you going to use analysis of DAA? Yeah. Well, somehow in my head, it's always like drug enforcement administration, but I believe this is probably another shortcut, probably data development analysis. So please, floor is yours.
Thank you. Thank you, Beata. So let me start this presentation thanking to Marzena to give me the opportunity to stay here in this fantastic conference and fantastic city. And my name is Massimo Castaldi. I am full professor of economics and managerial engineering at University of L'Aquila. L'Aquila is a small city located 100 kilometers from Rome. This research I present to you is a part of a big project called Peace, Protecting the Environment, Advances in Circular Economy, founded by the Italian Ministry of Research and involving 5 universities in Italy, which is the aim of the paper. So, you know, there is an intense debate in Italy, but also in Europe, on water industry and its efficiency. So we know that there is a lot of researcher, professor, and policymaker that are studying new strategies in order to determine an increase in efficiency of water utilities. But it's important to study the efficiency of the water industry, not only from an economic point of view, as we do in the past, but also considering sustainability. Now, here you can see the 5 steps to water sustainability. The first one is reduce, so the 5R, reduce water losses, reuse water, recycle wastewater, restore water to the source at same quality, and recover resources from wastewater. Now, in this research, we consider only the first point, the reduction of water losses. The reduction of water losses is very key variable because we especially need to reduce drastically the water losses. What is the problem with the relation with water losses and sustainability? The presence of water losses produces a lot of problems in the 3 pillars of sustainability, the social, the environmental, and the economic pillars. In the first one, if we consider the environmental sustainability sphere, the presence of water losses causes problems in environment. For example, wasted resources, the impossibility to recycle and reuse. But if you consider also the economic sustainability sphere, the presence of water losses produce other problems. For example, water not paid for and related economic damage for the operator or the firm that provide the service, the increase of energy consumption for pumping activities, opening of temporary roadworks for repair networks. And finally, if you consider the social sustainability sphere, we have a lot of problems related to risk of damage to things and persons, loss of security. So, for this reason, in Italy, we want to drastically reduce the water losses. In fact, we have a very big share, a very large share of water losses, about 41%. And this is one of the main objectives of one of the SDG, in particular SDG 6. And this is one of the big problems in Italy. We want to reduce drastically water losses. Especially in the south, we have a share of 50% of water losses. This is a very, very dramatic number, especially if we compare this number with Europe. Europe, with an average of 23% of water losses. So this is the problem we have to face in Italy. So let me see something about the integrated hydric or water service we have in Italy. So this service has a big transformation in the last 3 decades for privatization, liberalization process, regulation process. I don't have time to explain all the characteristics of the service, but I want to underline 3 points. The first point is we have to consider some territories, small territories, and in these territories, the service is integrated in the sense that there is only one company that provides the services. The entire service is provided by only one company. The second point is the separation to control with the management of the service. And the third point is that the tariff must be completely cover the cost. So in this way, it's impossible to obtain a vertical integration within the heterogeneous activities of distribution, treatment, and sewage, and the horizontal integration on the sufficiently big area for attaining economy of scale. So what is the model I present to you? So we want to calculate, we want to define which is the efficiency of the utilities company providing water services. So we use a well-known methodology called DEA, data envelope analysis. And this methodology allows to calculate the efficiency of the utilities. This efficiency can be obtained considering an output or input objective. This means that it can be output-oriented or input-oriented. If we consider an output-oriented method, this means that we want to maximize output given a given level of inputs. If we want to consider the input-oriented analysis, we want to minimize the input given a given level of output. Again, it's possible to obtain two different kinds of application, constant return on scale on variable return on scale. We want to consider the effect economy of scale, which is the variable we have considered in our analysis. From the point of the input, we have considered cost. From the output, we have considered three variables: water distributed, percentage delivered of water, and network length. The second variable is very important because it represents practically the water losses on the network. The sample. So we consider 68 companies in Italy providing water service, and practically 75% of all the companies in Italy providing water services. These companies are located on the entire territory. Notice that, only to give you an information, the territories in the north of the country are rich of water because we have a lot of lake, we have a lot of rivers. The company located in the center, in the south, has a big problem because the water is scarcer. It's possible to divide the companies considered in the sample by ownership type. So we have considered private companies, public companies, and mixed companies. So we have a part of mixed, public, and part private. And it's possible to divide the companies by sides. So we have small, medium, large, extra large companies related to the financial results. So this is financial division. Let me show you the results. What is the period of the observation of the data? It's between 2019 to 2021, and you can see that in this period, practically the efficiency is stable during time. It's very stable. And if we consider that BCC means variable return on scale and CCR means constant return on scale, the results related to the variable return on scales are better with respect to the constant, but this is expected. Here you can see the results. As you can see, I show you only the result related to the output-oriented model with a variable return on scale. And you can see that the number of company fully efficient is 26 on 68, and are practically okay. The fully efficient firms are located in the northwest of the country, but we have two interesting results related to two firms in the south. If we consider the results, the fully efficiently considering a constant return on scale are 28% of the sample. If we consider the variable return on scale as 42% of the sample. Now, let me see something about the results related to the company size. As you can see here, notice that the small firms have a better results related to medium and large companies. Notice that the size of the company is not a variable that can be controlled by the firm because it's given by other aspects. For example, the population, the characteristic of the territory, and other variables, for example, given by the policymaker. So size cannot change in the short period, in the short run. Here you can see the results with respect to the property type. As you can see here, notice that the public companies perform higher with the better efficiency respect to the mixed firm or private. This is due to the fact that normally public firms are more interested to environmental variable, for example, the quality of water and other things, so are more linked to the population. Here you can see again the results with respect to the geographical localization. As you can see that the best results are obtained in northwest of the country and the worst are obtained in the center. And so I can finish my presentation telling something. First of all, this result confirms other results we have made in the past that public-owned companies have the highest efficiency score respect to other companies. But now we have considered in this research a large sample with a lot of companies. And the thing very important, we have considered a new, it's important sustainable variable, key variable, the water losses that are very important we consider sustainability. The third point is related to the fact that the highest efficiency is located in the northwest of the country. But this is expected because in the south and in the center of the city, the country, we have companies with a very high level of water losses respect to the northwest and the north. So what would you have to do in the future? First of all, we have to consider all the companies, because in this research we consider practically 75% of the companies in Italy. But you have to conclude this gap, so we have to consider all the companies in Italy. The second point, very important, you have to add new sustainable variable, for example, related to the quality of the water, related to the pressure, for example, or the other very important variable, for example, the reuse or the recycle of the water. And then you have to do some international comparison, maybe with other countries, in order to underline the weakness and the strength of each country. So thank you very much for the attention. This is my email. If you want to read me, thank you very much for the attention.
Thank you, Massimo. Just very short question. What is the main reason of such a high losses? What is the reason for such a high losses in Italy of the water?
What is
the main reason? What is the cause?
The problem is that we want to reduce the water losses. And so this is, the thing is that where you have to do, the first thing is where it is necessary to put new strategies in order to do this.
Thank you. Thank you. Now I would like to ask the last speaker, Jolita. It's here, yes. From the Kaunas University in Lithuania. And we are all implementing circular economy, but that's very important to monitor the progress and this implementation. So Jolita, please tell us about it.
Yes, thank you. So, as it was introduced, I will talk about circular economy in water and wastewater sector in Lithuania. For this assessment, some indicators are needed, and here you can see the ones that we used for our study. And they are clustered into indicators that talk about prevention or reduction, those that talk about reclamation, removal, reuse, recycling, and recovery. Lithuania, as you all know, is a neighbor of Poland, north to the Poland, but we are just much smaller. And this study is largely about agglomerations that are above 2,000 population equivalents. And we have just some 65 such agglomerations in the country, and only 4 of them are more than 100,000 population equivalents. So we are not very big ones. And What about data? We used all different open data sources, databases, statistics, scientific literature, and also approached wastewater companies themselves. To start with prevention, the overall amount of wastewater, although fluctuating, it is, if we look at longer time scale, it is rather stable actually. But if we come now to the main sectors who are users of water, it is rather different to what Roberta was telling before the lunch. The very main user is energy sector, but it's mainly for energy production and so on, so it's surface water. If we exclude energy, then domestic purposes are dominating, it's some 58% even, then followed by industry, fisheries, and agriculture is really just tiny percentage, as you can see here. With regard to industrial usage, this, I don't know if, can I, yeah, show like this. So water productivity, which shows economic output per cubic meter of fresh water abstracted, it's really increasing. It's tripled during some 15 years. This can be attributed probably to several reasons, to really to better usage, better efficiency of water use, but could be also to structural changes in industries, let's say increase of IT sector or similar courses. If we come to domestic uses, I don't know if I'm not, if it's visible through me. So Lithuania is this bottom line, and it is plotted here against some other European countries. And even if our consumption is increasing now, but we are still probably those that use the lowest amount of domestic water per person and per capita, and also in general amounts. But still this usage, it is increasing, and here might be several reasons, but one important what water supply companies notice, that there is really clear increase in water usage in hot summer times, in mornings and evenings, when people start watering their lawns, flowers, probably vegetables, and so on. So this shows that due to climate change and changing habits, water for irrigation becomes necessary, and so this is with domestic use. And here you can see connection to centralized wastewater collection and treatment. Of course, it is not directly a prevention indicator. Nevertheless, it is important. Different inspections have observed that, namely, individual treatment has the biggest risk to not really treat water to the required parameters, and also when you collect water to centralize bigger treatment, there is better, it is more feasible to then recover resources from it. So the progress is really very, very clear. It's from 2003, it was just some 27% of water, of centralized collection, and now it is over 75% overall. But if we look at bigger agglomerations, so it is the numbers are much bigger already. If we come now to reclamation and removal, treatment efficiency for nitrogen and phosphorus is rather varying actually. It is mostly varying for smaller wastewater treatment plants. And is this efficiency enough on the country level? So if we look at plot over time scale, In 2012-13, it was really very good treatment degree that was achieved, but now we have some increase in water that we say that it's insufficiently treated. And one of the main reasons is our biggest wastewater treatment plant in the capital city, where a lot of people moved to that region, and it simply can hardly cope with this increased load of wastewater. And now they are finalizing reconstruction and trying to cope with the situation. It's still about whether it is enough for this level of treatment that we achieve. And the example here is for phosphorus from Helcom. That's about discharges to Baltic Sea. And Lithuania has targets for Baltic proper and Gulf of Riga. So for Gulf of Riga, we have achieved the required reduction of national inputs, and so we are good here, but with regard to Baltic proper, we are still above that, so still some challenges. Share of inorganic fraction is actually rather big, both for nitrogen and for phosphorus, but it's again from biggest wastewater treatment plants. If we exclude them from calculations, then this share would be drastically lower. Biological dephosphation potential shows that, in many cases, addition of chemicals is necessary to achieve the required purification. So if it's below 50, we have this need, and you can see that it's, in a lot of cases, it is above 50. And in reality, majority of wastewater treatment plants, it's also due to requirements of Urban Wastewater Treatment Directive, they do have tertiary treatment, so removal of nitrogen and phosphorus. So it's 87% of treatment plants are with this tertiary treatment. About pollution of sludge a little bit, because about 1/3 of wastewater treatment plants, they practice to send some sludge to agriculture, and therefore it is important to look at pollution level. And pollutant content indicator, in average from literature, it is about 0.5 in different untreated sludge from different wastewater treatment plants. In Lithuania, the average is 0.16, so it's well below this average. It is even below a commercial single superphosphate, for what it would be 0.23. But if we look at individual treatment plants, so you can see variability is really a big one. So not, of course, not average, but particular sludge and particular treatment plant is important. It is mainly zinc, cadmium, sometimes mercury that is exceeded. And now about reuse and recovery. It's again a little bit to what was shown before the coffee break. So in Lithuania, it is 0 for reuse and then for recycling. You showed from this general report that there was some little number for Lithuania for reuse, but I guess it could be probably from industrial wastewater, because industries, they do practice reuse, but not really municipal wastewater treatment plants. One of the reasons, again, coming back to agriculture, to this little percentage of water in agricultural sector, so you can see here an explanation. It was only 9 farms with this percentage of water that goes to irrigation. Although the need for irrigation is increasing, so maybe one day Lithuania will also join this need for water reuse in agriculture. With regard to recovery, recovery can be of materials or of energy in the form of bio-waste or heat. Unfortunately, we have not identified anything interesting, if I could say like this. For materials, it is mainly usage of sewage sludge in agriculture, direct use or via composting. Usage of sludge undergoes really big changes. Some 20 years ago, the biggest part was just going to polygons. Then the situation changed, and nowadays much bigger share started going to incineration. It was only in 2017 when some first sludge was incinerated, and now it reached, it's over 30% already. But in fact, it's mainly incinerated in cement kiln. So no then real some more advanced recovery techniques, neither for phosphorus nor for nitrogen, actually. And biogas production is taking place, so some biogas is recovered, and then it is used either for heat or electricity generation. So to summarize, wastewater sector is largely compliant with legal requirements, but too few still solutions for real circularity could be identified, so we still have a lot to do.
Ladies and gentlemen, we are after time, and the next session is in 15 minutes, so I don't want to take your break. Thank you very much to all speakers, and I encourage you, if you have some questions, please approach our speakers and just ask them. Thank you so much for sharing your experience and knowledge, and yes, welcome back in 15 minutes. Thank you.
Hello, everyone. Good afternoon. I would like to... I'm waiting. It's a great pleasure to me to be the chairman of the session. This is the last session for today, but not for the whole conference. We have the session of the project supporting circular economy in the water and sewage sector. My name is Renata Tomczak-Wanzel, and I'm working in Aquatinkowi. Aquatinkowi is a research institute in Norway. So we have very limited time and 6 very interesting presentations. So let's start it as soon as possible. Don't get more delay. So I would like to invite Marzena Smol from Mineral and Energy Economy Research Institute and from Polish Academy of Science. Marzena will be present some results from circular economy in water sector, our water circular economy management project. So please, Marzena.
Thank you very much, Beata, for this introduction. Renata, sorry. Beata and Renata, all the time together. Sorry for that. Okay, so I will continue the presentation regarding the project Water Sea Management that you already know from the afternoon session. So our project is divided into 2 very important parts. The first one is dedicated to the recovery and reuse of water that is produced like rainwater, and also some part of our results will be dedicated to the municipal wastewater. And it is connected with the regulation from 2020, which was already also deeply presented by Roberta in the afternoon session. The second part of our project, which basically was the most important part because this call was dedicated to the social and education campaigns, with the elements dedicated to the technologies. But the most important was the campaign dedicated to the awareness of the water management in the circular economy. So the project you already know. We've received almost 2 million zlotys for the 2.5-year project, which was implemented by the 4 actors from Poland and from Norway. And the main objective of the project was to accelerate the circular transformation in Poland. And it's very important because this is the international project, but the activities were dedicated to the Polish citizens in the aspect of the social campaign, and also water recovery technology has been demonstrated in Polish company. The objectives were dedicated to the technology, social campaign, and transfer of knowledge. The team you already know. And we are the Mineral and Energy Economy Research Institute, and we are working basically on the water reuse and water management and also recovery of nutrients, including the phosphorus in our division. Aquatinkowi, Renata and Beata, all the time together, so sorry for my little mistake. We have the green bag with Dariusz, who will present the results of the installation for the water recovery. And also we have Optimus Foundation, and as I mentioned previously, we will work on the gender equality in the future, I think. We had 5 subtasks in our project, and first one was dedicated to the identification of the problem and diagnosis of the problem, and to set up some solutions that could be provided in our project. And this first work package was led by our institute, and it was the initial step to go further with this water reuse topic. The second was dedicated to the development of the Atlas of the Good Practices, and we jointly developed the Atlas that is published on our webpage. So you are very, very welcome to see which kind of the technologies support the water reuse in all Europe, and not only European Union countries, because we have also very good Norway examples. The third one was dedicated to the development of the technology, and we have the technology that is in Kłobuck, near to the Częstochowa city, and Dariusz, after me, will present the results of this installation for the water recovery and reuse. The fourth one is dedicated to the development of some model solutions. This is something like algorithm, which should support the decision makers for the implementation or not implementation, the water recovery and reuse solutions. And of course, we would like to have some messages here for the decision makers. Please do it in the future. And the last one was the biggest part of our project, and it was the free social campaigns dedicated to the various stakeholders. And as I mentioned before, we reached like proven participants in our events, and the audience of our social and education materials around 3 million people. So it's really, really impressive for us. Yeah, so regarding the social campaign, now it's over. We have been asked many times if we will organize more education activities. However, I have to say that during this 2.5 years, it was really challenging, including my little break in scientific working. It was really challenging to reach these 3 million people, and our events were dedicated to the people in general, including some workshops, seminars for kids. The second social campaign was dedicated to the specialists, including water and sewage managers, and also other specialists who were interested in the water and wastewater sector from the perspective of the circular economy implementation. And the last one, that were the scientists, including students, PhD students, and also general workers at the universities and research institutions, who also very actively joined our events. Yeah, so this is the numbers that we achieved during last 2.5 years. Workshops, seminars, summer school promotion materials, education materials, trainings, movies, and yeah, it was taking a lot of time to prepare the materials, and they are for free available on our webpage, including the YouTube channel where we have the webinars and also promotion movies about our projects, where you can also find some deep information about it. And now I would like to ask the technical staff for our movie.
Woda jest jednym z najważniejszych zasobów naturalnych na naszej planecie. Niestety z uwagi na postępujące zmiany klimatu oraz niewłaściwe gospodarowanie tym surowcem staje się towarem deficytowym. Projekt Wodogazowanie w praktyce ma na celu dostarczenie nowych, innowacyjnych rozwiązań pozwalających na inteligentne magazynowanie wody deszczowej, a także wykorzystanie wody wtórnej do mycia i konserwacji narzędzi czy urządzeń lub nawadniania roślin. Odwiedź naszą stronę internetową i dowiedz się więcej.
Thank you very much. That was a very short movie that was emitted in the TV. I will not say which one, but it was quite nice to see our actors who are our researchers, because you can see Dariusz in this movie as well. Yeah, it was quite a nice experience, but it really took some time, and I think that there are dedicated people who are developing this as well. So this is only the screen from the previous presentation, my previous presentation, and Dariusz will say more words about those tomatoes and installation. And here you can also have some access to our education and promotion materials. Yeah, and that's all from my side. I'm very happy that I had the possibility to share those short results with you today. Thank you very much.
Now, As Marzena said, then we would like to invite Dariusz Włóka from company Greenback. Dariusz and the company Greenback is the part of our project Wodogozowanie. And Dariusz will talk more about the results of our project. So, please.
A gdzie jest zmieniarka?
Tu jest mównica, a tu jest zmieniarka i dokładnie tu masz.
Ten? Dobra. Okay, hello everyone. My name is Dariusz Włóka and I'm from Greenback Company, and together with Institute and other partners, we have worked during the development of the new installation for the water recovery and rainwater reuse in the garden use and also for the technical uses. The general goal of our work was to develop an innovative installation for the water recovery, but not only for the recovery of rainwater and green water, but also to provide some new solutions in order to have a wider range of application, and applications such as the treatment of the purified water or treatment of the treatment of the wastewater during the final stage of the water treatment, for example, in the wastewater treatment plants. So our technology was not only for the usage during the realization during the design and building of the installation, but also to the wide range of application that I will show a little bit later. Our installation includes the usage of two types of water sources, and the first type was, of course, rainwater, and the second type is the grey water. And our installation was designed in order to combine those two sources in order to provide a solution that could be used for the watering of plants, and in order to provide the full spectrum of the requirements for this for the application in garden or for example to watering plants in greenhouses. Our installation was built from I think that was built from the four sections, and first section includes the collection of the rainwater water that was installed on the two buildings, and this installation includes the collection system and also water storage system. Next section includes the water purification systems, and this includes the water purification station that includes also the innovation that was implemented during the building of this installation. And the third section of the installation includes the water reuse, the grey water reuse systems. And this section of installation are designed in order to fully cover the recycling of water that are used during, for example, the watering of some tools during the realization of garden works or something or other tasks that are realized on the installation. And the installation was located in the Kłobuck location, and you can see on the slide the picture, the photograph from the above that shows that two buildings was included in order to collect rainwater, and also a third object that includes the recovery of grey water on the garden section. On the next slide, I have presented you some pictures of the installation, how it looks like. You can also
see those installation on the movie that Marzena have presented you. But what can you see on this picture? You can see two of the two garden houses that was included for the watering, for the watering of plants, and also the water purification station that is located in this object on the right of this picture. On the next slide, I can show you also how it looks like from the inside of the garden house, and as you can see, we have used those water that was recovered from the rainwater and also from the grey water in order to water plants with using of dropping systems and in order to use the water as efficient as it was possible. But this was only a short demonstration of the installation, but we also conducted some additional studies in order to test some innovative solutions. For example, some new filtration methods, water filtration methods, in order to provide some additional features during the treatment of collected water and in order to increase the safety and the efficiency of the use of the recycled water or even water collected from the rainwater collection systems. And during our research, we have conducted two studies, and those studies include two filtration methods that was based on the small filtration beds and the large-scale filtration beds. And those filtration beds was designed from the new mineral systems that was consisted from the calcium-based minerals, and those systems was designed in order to provide the opportunity to recover not only to purify the water, but also to recover some biogenic materials such as phosphorus or nitrogen. And in case of results that we have obtained during those two filtration methods that we have provided, we have realized several tests. And as you can see on this slide, we have presented you some results that we were able to achieve during the first vegetation season. And first of all, we have measured the pH and some basic physicochemical parameters of the water collected before and after the filtration. And as you probably can see, we were able to, on this two tables, both the tables show that we were able to significantly decrease the turbidity of the water that was treated with the use of this method. And additionally, we have also decreased the water oxidoreduction potential and slightly increased the pH value and also slightly increased the water conductivity, which could be resulted from some washing out of some compounds, calcium-based compounds from the filtration beds. But more interesting results can be shown in case of phosphorus, because we were able to achieve some interesting results. With use of our new innovative filtration beds, in case of the smaller beds with these small experiments, the results was not so significant because we have achieved around 10% of the phosphorus recovery. But when we have increased the size of the filter, which was also associated with the increased time of the contact from water to the filtration particles, the removal of phosphorus was on the point that are shown on the right side of this slide. And as you probably can see, all the tested samples show around 80% of the phosphorus removal from the water that was passed through the filtration beds. In case of nitrogen, results was a little bit smaller, not so significant as in case of the phosphorus, but also some removals was observed, and those removals was on the round of 30 to 40%. So some removal of nitrogen was also observed. But how this applicability can be converted from our installation into other installation, for example, during the treatment of the technical water that could be recovered in some systems. And on this slide we have presented some demonstrated solutions that we have developed, and as you probably can see, filter that is built from the filtration bed, and also with the additional use of the UV lamp can be applied in almost all situations that require additional filtration of water, or even the removal of phosphorus from the water systems. But also we have provided some opportunity to something happened, I think. Okay. Okay, this slide, and as you probably can see, we have also developed some model that could be applied for the wastewater treatment plants. And by the utilizing of this method during the treatment of the water, of the purified wastewater on the final stage of water purification, we can provide the solution that could not only purify the water, but also provide some additional material in the form of the filtration bed that has been used, and we can reuse those filtration bed and add this material into the sewage sludge in order to increase its fertility potential and provide some solution for the new fertilization options. So we have got a joint effect. We have got the removal of phosphorus, but also the opportunity to produce fertilizers with the increased phosphorus potential, which can be considered as a circular economy method. And going to the conclusions, I think that going to the conclusions, I think that the realization of the CEwater project provides some opportunities not only for the water recycling and for the reuse of the rainwater in order to watering plants, but also for some other sectors such as wastewater treatment plants and so on. And if you, of course, have got some additional questions and would like to know a little bit more about those methods and those technologies, we can also answer any of the questions that you have today or even tomorrow. We are available for all additional questions. Thank you very much.
Thank you very much, Dariusz. What's a pity we cannot try the taste of this tomato because it was our project, so we were not able, unfortunately. But probably, as Marzena said, taste was great. So our next speaker, Klara Ram from Warsaw University of Technology and from the Chamber of Economy Polish Waterworks from Poland. Klara will present water reuse in the Baltic Sea region, some possibilities and risks.
Thank you, Marzena, for inviting me to present the result of the first steps of the project we conduct in scope of Interreg. But before this, I would like just to share with you some ideas that we have Europe of two-speed Europe. So we have really very well advanced southern part of Europe that recover and reuse a lot of water because they must. They have to do it because of the water scarcity and climate change. So we have already good examples from southern part of Europe. However, when we see Baltic Sea region, we see such pictures taken just in the Baltic Sea region, so a lot of water. So why water recovery? Is it really a challenge for our region? So when we see at the HELCOM, at the result of HELCOM report from 2021, there is a lot of information about the impact of climate change to the water management and the water states in Europe. So rising air temperature, which impact the sea and waters in our region, but also rising sea water temperature, which also influences after all the local Baltic Sea region climate. And what is very important, they are extreme river flows. So there is much more event than we have too much or too little water. So we were used to have a lot of water in our rivers during summer when snow melted, and after less and less. Now we have more and more event that there is too much water, so a lot of water, and after we are also concerned by the water scarcity. And eutrophication, that it's still a very big challenge of the Baltic Sea region. So we can see that maybe water use in some part of the region is very important, so that's why we decided to launch a project about water use in the Baltic Sea region. So it is financed by the Interreg Baltic Sea. And we decided, so thanks to Marzena and others, we really described what we want to do, and this project is ongoing. So we are about 1 year of preparation, and now we are launching our pilots. And the challenge seems very easy, so just to remove this 0.1% of contaminants from this wastewater. But it is challenging, you are aware that it is not so easy. So what we concentrate on is just on this water use, so this water reclamation plant, like it's named by the regulation already mentioned by Roberta. So it is concentrated, this regulation, on agriculture. However, we base on it because there is only one regulation in Europe that we can base on, except norms and standards, ISO standards. So that's why we will try to take urban wastewater and recover water for it. So what are the first results of the report that was presented by Oskar Spromalis and the team of University of Latvia? They assessed what happens in the Baltic Sea region. So you can see that it is already obvious that climate change also is harming water resources in our region, and also the increasing deterioration of waters, contamination, micropollutants, etc. So they are also impacting water management in the Baltic Sea region. So there is some regulation, like this regulation for 2027-41, but there is also in the Baltic Sea region a lot of bottom-up initiatives. So we have this regulation, however, we're trying to do something in a very small scale. So also in our project, we are trying to do something in a small scale. So build greenhouses, for example, on Samso Island, or irrigate some selected part of city green areas in Jurmala city. So there are really some attempt in small scale how to after the piloting, so after this pilot, how to develop a bigger project. And this water exploitation index, already also mentioned by Roberta, it's not so bad. However, there are some parts of Poland, for example, or Denmark, and also Baltic islands, like Gotland, Holland, which are very concerned by water scarcity already. And we also launched a survey, so among Polish wastewater treatment plant utilities. So thanks to my association, Chamber of Economy Polish Water Work, we launched a survey among about more than 500 urban wastewater treatment plant operators, asking them what they think about it, how they see it. And so they use treated wastewater internally, and it also was mentioned by President of Kraków Waters that it is something that is common. So 80% of Polish wastewater treatment plant operators, they use also treated wastewater for their internal purposes. So it is good. It is a good step toward external use. And they were asking if they see a potential for water use. So you can see that, yes, 74% of urban wastewater treatment plant operators, they answered that, yes, it is a potential. We received about, because this survey was treated by Marzena and myself, and we received about more than 100 answers. So it's 20% of ask wastewater treatment plant operators, so all big ones, they answered our survey. So you can see that there is a potential. So what are barriers? 80% of them just mentioned microbiological hazards, so micropollutants, so they are afraid about managing this pollution, that they will not remove it properly in these water reclamation plants, and lack of legal requirement in Poland. So this regulation of INA, they really want to have something more concrete how to reuse water locally. Also high investment costs, so profitability, it's still problematic. And lack of recipients, so Polish agriculture is very reluctant. They don't need this water because they have a lot of support from the state, for example, and other possibilities to use, for example, groundwater and to use river water. So they really don't feel the need to go in such a complicated project like water use from urban wastewater. I hope that it will change. And opportunities. So we have a lot of good examples, not only from the southern part of Europe, but also from US, from Australia that we can base on. We have ISO standards, so something is already done that we can base on. We have a lot of technologies, so you know that we can produce water from almost everything, every liquid, but it is the concern, the issue of costs, how we can invest in it. We see the interest of the urban wastewater treatment plant operators, so they really want to invest in such solutions, but reluctance of agriculture, so rather we see that there is a potential of water use, but in urban areas, in cities, irrigating green areas, but not just in agriculture. It is too complicated and still too risky in the region. There is also an issue of confidence of users, so this YAG factor, so they are also reluctant, they don't want to use this water produced from wastewater. So Marzena already presented all these campaigns of education, etc. It is very important to educate people and also to be transparent how we manage with it. And risk, we are working on it in our project, so just to prepare guidelines how to manage risk, to reduce it, to minimize it. And now we launch survey in different Baltic Sea region countries So please, if you can just answer, fill in this questionnaire, you will get it in the presentation, but also you can find it in the CEwater project site. So we will also see what happens in another remaining Baltic Sea countries. Thank you for your attention.
As we see, we have a lot to do still under water reuse. We have a lot of possibilities. So let's check how it works in Krakow. So I would like to invite Bartosz Łuszczek from Krakow Water, and we will see how it works in Krakow, water recovery and reuse in Krakow Water.
Thank you very much. Okay, good afternoon. I will just show you a short presentation based on our experience in wastewater recovery. Okay. I work in Krakow Water, but I also work in Chamber of Commerce Polish Waterworks as Clara. Therefore, some European ideas, European requirements I'm familiar with it a little bit. We can see now a lot of challenges as a sector, mostly based on Drinking Water Directive implementation and Urban Wastewater Treatment Directive that is in progress now. In these regulations, we can see some elements of circularity. Obviously, the water reuse in wastewater treatment directive as kind of encouraging to reuse water, but there are some elements of losses monitoring, energy neutrality, and nitrogen and phosphorus recovery that are directly connected with circular economy. As Krakow Water, we are realizing a lot of projects, R&D projects. Well, the water and wastewater sector is a specific sector that naturally has a big research potential based on assets, just on assets like wastewater treatment plant, water treatment plant, and so on. We just need to have an idea of project, and we just need to build a research potential based on a laboratory, on our cooperation with some universities. We use our potential here in different projects with waste processing, resources recovery, process development, energy projects, and water recovery, and some IT projects also. The last project of extension of our research potential was based on our laboratory with new analytics that we finished this project last year. And now we are the only laboratory in Polish water sector that can measure all parameters from new Drinking Water Directive. We're the first laboratory in Poland. Next step, wastewater, sludge, and biogas analytics. We are preparing now a project to enlarge our potential in this analysis. Here is just one example of our project. I'm showing it because you can see the effect of the project on Wednesday as the site visit. It's here on this water treatment plant, and it is pilot plant based on Vistula River. I think it's interesting to see this pilot plant. We have also, in this project, we have also an idea to develop possibilities of disinfection based on concentrate from reversed osmosis. We are trying to see what is the effect of producing the disinfectants from the concentrate from reversed osmosis. Yep, it's interesting because it's one of the circular economy paths in the water sector, as if it will be possible. It will be possible. It will. Okay. You have a few examples of our circular economy projects based on water, energy, waste, and materials. You can see that they are connected with water treatment and wastewater treatment also. And the water recovery. We are using our wastewater. I think it's obvious that we need to recover it for purposes on the urban wastewater treatment plant, as Clara mentioned before. But also we use it for cleaning sewers and also for washing streets in the city. The last opportunity is interesting because there's no legislation in it. Maybe some more for a few minutes. Okay. Clara mentioned the consumption of water and wastewater in the wastewater treatment plant. It's just an example from our plant called Płaszów, the biggest wastewater treatment plant in Kraków, about 800,000 people equivalent, and we can see the consumption. What is important? Okay, we can assess the whole yearly consumption of water, but the problem, the technological problem in the wastewater treatment is that this demanding is just for few seconds, few minutes, and we have high flows, we need higher pressure, and so on. And you can see the biggest demandings in different parts of different processes in a wastewater treatment plant, like especially screens and screenings, washing, sand separators, grid separators, and sludge dewatering. These are processes that are really that need a lot of water. One important thing is that we are operating to have some circularity in the waste processing, as grid, sand, or screenings. If we would like to have cleaner grid, cleaner screenings, you can see our sand that we are trying to reuse. You need more water and higher pressure, and so on and so on. Therefore, we are trying to use a lot of wastewater reused rather than drinking water. As we can see, there is a drinking water consumption of whole plant with every purpose, also with staff needs and so on and so on. You can see that it was rising for a few years, but after this we made some projects of wastewater recovery. We have pumping station with filters, with UV disinfection. And and we prepared next steps, yeah, network development and tank to pressure compensation and so on. And this will be our new idea, but it is only connected with process water for wastewater treatment plant. Another thing, washing streets. It was the idea was very interesting, but we didn't know how to manage the quality because there's no regulation on it in Europe and in Poland also. Yeah, that we decided, okay, we can do it, but the first thing that we need to have it's disinfection, and it's the need to be sure that it is just safe. And we just built a small plant, small disinfection plant, tank and dosage of sodium hypochlorite. It's just after UV disinfection. And we can use it directly on the streets because you can see that there's no bacteria in it. Okay, we have a higher chlorine concentration in it. It's obvious, but we can use it on the street now. It's about 10,000 cubic meters per year, something like this. And we just sell this water to the cleaning company. Okay. There are a lot of factors to monitor the wastewater reuse. It's last slide, really. But we are using just the one of the easiest for us. It's just avoided drinking water consumption factor that shows what share of drinking water is replaced by reused water. And for now, for Płaszów wastewater treatment plant, it's about 66%. And that's all for now. Thank you.
Thank you very much. Now we are jumping from Poland to Sweden. I would like to invite Merdat Arshadi from Swedish University of Agriculture Science, and we would like Merdat will tell us something about the circular economy in forestry.
Yes, thank you, Renata. Thank you, Professor Marcena, for inviting us to this meeting to be able to present our project. Yeah. Okay. It is, I would call it as a sister project to your project because it's circular economy. You are working with water and we are working with forestry material, but we have some interaction also in this project with water, because we are going to use some forestry material in water treatment plants and also industrial waste water by some products. This project started last year and continued until the 3 years. The main objective of this project is to use unutilized forestry residues or side streams to new products, to value product. But by that it means that many of forestry materials today used, actually, we have not much that it is unused, but we have identified a kind of material that is not used today and also have a good logistics possibilities. This is important to see. This is not just taking some products somewhere in the forest. In this project, we have 12 partners from 5 countries in Baltic Sea region, and also 18 associated partners. And also, we hopefully, by the end of project, we have engaged totally 59 target groups in this project. That is, include organizations, politicians, and all of the other people that will help in this project. this is the group from partners group that we have some of you here in this meeting. And also this associated partner that we have, Swedish Water and all of the different companies that may have interest in this project. Yeah, okay, it is just 3 parts, but we have some activities. I would like to tell about some activities that we have. The first thing, we need to mapping where we can find this material in the forest, and how is the logistic. And we have done a map of this Baltic Sea region already, and the map will be available that you can see where the side stream is existing. Then we are going to use, in the second part, you are going to use conifer needles biomass as added value to some products. For example, in meat analog, we are going to work at Kaunas University. We are going to use some of these needles in production of meat analogs. We have done also extractives from bark, from different bark, and and we have also market analysis, and also in the end bioash characterization to reuse as fertilizer. In second part, we are going to use the extract from that is wood extract and use it as antimicrobial agent in wastewater treatment plants and also in pulp and paper production. Because in pulp and paper production, they use biocides. We are going to use it as biocide replacement to use it instead of chemicals that using today. Some of them very nasty chemicals in pulp and paper. Because they have a limitation of using water in the process, they recirculate this water several times. And during that time, they get a lot of microorganisms that activating. And they need to add a lot of biocides to kill all of these microorganisms. And this is a big process. Like for one ton of biomass, they need at least maximum, they can use 10 cubic meter of water. And they need to recirculate all the time. And this kind of problem we have tested, and it actually works with some of our product. We have CE business model, we have pilot plan for meat analog, we have techno-economic studies that we are going to do, and some policy recommendations that we are going to present. And we have advisory board, and this is a total budget of the project during 3 years. And some of the results you can see here, as I already mentioned, we have already get some of the good results. I'm not going to the details now, but this result available, and we are halfway in the project, and hopefully we are going to finalize our aims in the project. Yes, I think almost I done. Yes, and we had every 6 months we had a meeting, like this kind of meeting, and we have next meeting in Kaunas University in June this year. But this is our already meetings that we have already had. And it's some picture from the group during the meeting. Thank you very much.
Thank you very much for a very short presentation, but very essential presentation. Now, our last speaker for today, I would like to invite Magdalena Gajewska from Gdańsk University of Technology. So we are back to Poland, and Magdalena will present some issue regarding the rainwater and swimming pool water reuse, and some case study from this. Yes, please.
Okay, good afternoon. I hope that you are not falling asleep. So please wake up for 10 minutes. And first of all, I would like to express my great thanks to Professor Small and Dr. Clara, for being here in this great event. And actually, I'm going to present you part of the work which I am responsible for, but actually it's a twins project with CEwater. We got this label, which is Waterman project promoting water reuse in the Baltic Sea region. And as you can see in brief, in nutshell, so-called, we have a lot of partners, we have a lot of associate partners, and the project is ongoing, like this CEwater. We have quite nice money, as you can see. And what we realized, our diagnosis was that it's not enough to have the model strategies, pilot measures, but we need also to have practice guidelines and target advices on top. So our approach is to create so-called Baltic Sea region water reuse toolbox, methodological guidelines, and replication blueprints. It means that we are focusing on pilots. And in this way, we produce success story. At the very end, we are going to produce Baltic Sea region water reuse helpdesk. So, very briefly, as you can see here, scope of our pilot measures are two target. First is recirculation of retained stormwater to reuse, and then the second one is the, oops, sorry, too fast. And the second is reuse of treated wastewater as it's in CEwater. So we are focusing on these two measures. Our target group, as you can see, we have a lot of model regions and model strategies, like for example Vastervik. It was said before that they are gather rainwater in the pond and then they are producing snow, for example, during the winter season. They are using the water for other purposes, cleaning the streets and other. For example, in Bornholm, they are focusing on amendment of treatment from very small wastewater treatment plant in the so-called slow filter, and the German name is Schmutzdecker. So this is for some people very interesting and intriguing, that they are coming back to very old natural method of treatment, and then they are going to use the treated water for growing spinach seeds. So this is the idea. In the Bornholm, in the in the Berlin, they are not going to have real pilot, but they are going to have visibility study for reuse water in industry. So very huge job how to organize this. In this region, they are focusing also on collecting of rainwater, and in some case they are going to have the fontaine, and in Braniewo, which I am going to focus on. Now we have two cases. We have the reusing of swimming pool water for irrigation on football fields and creating urban rain gardens in the municipal sport center. So briefly, few words. As you can see, Braniewo is a small city around 6 kilometers from the border from Russia. And it's around 16,000 person equivalent, but they have a very nice sports center with football team, football fields, as you can see here. And they have a lot of issue with the pool water because it's cost a lot of money to maintain. So first, few words about the swimming pool. I am not person in charge of this. A colleague of mine, Professor Krzysztof Czerwionka, and his team, he's working on this. So here you have the results of the water which is drawn back from the system. And also some part of water from drawback of the filters. And after coagulation, because we foreseen that the best will be coagulation, the parameters looks quite nice, as you can see. And many people ask about total chloride because the water is chlorinated. But after the procedure, we are not facing the issue of chlorinating. And we foreseen this scheme of treatment. So first of all, we need to have a very big reservoir because the amount of water which could be reused, it's around 30 cubic meters. So we need this capacity. Then we have the equipment for reaction with the coagulants, then sludge tank and open retention tank. Also, the rainwater from the roof. I will show you in a moment what kind of roof we are talking about. But here we faced some issue because the construction of the swimming pool is not foreseen for so big reservoir tank under the ground. So it will cost a lot of money. So lesson learned, it's better to predict what you are going to do with your water in advance before you start to construct, for example, swimming pool or something like that. This is really very nice water which could be reused, but you need to be prepared for this. As you can see here, the cost in euro and in Polish zlotys, it's going to be really, really huge installation, and most likely the project will not able to cover the cost because we are not foreseeing this cost in the budget. Okay, so let's go to the next pilot, rain garden. This one is, of course, my part. And from the area view, you can already see what is the issue here. The issue is actually, as you can see, the roof of the swimming pool, and also the area which is really facing the heat island effect. So, as you can see here, this is parking lots, which is really concrete, and the temperature is around 22 Celsius degree, and the parking lot is as much as double. So you are taking the bath, and then you are in like an oven, almost. So our idea, of course, was to investigate the issues and the challenges. Our challenges is transformation of urban greenery into functional greenery, infrastructure greenery. Because we notice also here that it's beginning of June and the green grass is already yellow. And doesn't make any sense to water it because it's open space, no shadow. So this is the point. And rainwater retained at the point of origin. This is approach of Gdańsk city, actually. So what we did, we tried to look and try to behave like water. We investigate how the water is coming, where it's gathering, and what are the points in which we can collect the water. In the second stage, we investigate the microcatchment. Then we elaborate how much water we can get. And this is roof area, as you can see, with the estimation of 30 millimeters from each square meter. This is the approach which is recommended by Gdańskie Wody Company. We can achieve such amount of water which could be reused in the city for green grass growing or other purposes. And also we investigate the places where the water could be stored in the place of origin, as you can see. So we investigate around 5 places where the water could be retained in a place. For example, here water really guides you to the places where it really flows. And as you can see, having the inspiration from Gdańsk city, it's very easy to transform the place, the urban greenery, into infrastructure greenery using these jagger curbs. And we have at least 2 options. The first one, as you can see, flower meadows, retention flower beds, 2 parking places taken for greenery, greening the street slump, greening the rubbish heaps, retaining walls. And this is the first option, which will cost around 65,000 euro. And the second one, which is more advanced, I would say, more capacity for water, as you can see, and some planting, insect houses, so means that we will create biodiversity, and planting trees for making shadow. And this second option is more welcome by the municipality of Braniewo, but still it's a huge amount of money which needs to be allocated for this. So creating urban rain gardens means reducing the urban heat island, improving drainage of the parking lots, improving of local microclimate, aesthetic value, economic approach to green maintenance, because when you have the meadows, you don't need to really care about it. And increasing the awareness of inhabitants of Braniewo regarding the climate changes, and of course using the operation of green infrastructure. Stay in touch with us. Please visit the website of our project. It's still ongoing. And using this opportunity, I would like to invite you for the campus of Gdańsk University of Technology, when last year, within the project Horizon, with the acronym NICE, we construct so-called innovative rain gardens, which is dedicated for also treatment. Because if you would like to reuse, first of all, you need to treat. And we know that such microcatchment like urban streets are really very polluted. And that's why our idea was to construct such unit before real rain garden. So please invite us and I will guide you to this. Thank you very much.
Thank you very much, Magdalena. So the first day of our conference went by, so I would like to say thank you to all our presenters for nice presentation, and I'm really, really sure that all of us, we are looking forward for the next days of our conference. So, and let's meet together tomorrow, quite early morning, about 9. Yeah? We started at 9. So one more time, thank you very much.